Algorithm. As we know that a program is a collection of instructions, the language used to write a program is called a programming language. Before writing a program on the computer, every programmer must analyze the problem and write an algorithm to solve the problem. An algorithm is a set of steps in a sequential manner to solve a problem or to complete a task. The problem can be logical or mathematical. Algorithms are the building blocks of computer programs. They are important to programming as recipes are for cooking. An algorithm is always written in very simple words and precise language so that the steps can be understood easily by everyone. In computer terms, algorithm is the sequence of steps or computer operations which collectively solve a given problem. Characteristics of a good algorithm. The main characteristics of a good algorithm are precision. Each step is precisely defined. Uniqueness. Result of each step should be uniquely identified and only depend on the result of the preceding step. Finiteness. It should stop after a finite number of instructions are executed. Input. It should have well-defined input. Output. It should have well-defined output. Effective. It is measured in terms of time and space. Uses of an algorithm. Algorithm is commonly used for performing data processing, manipulating data, performing computer and mathematical operations, searching for a particular data. Writing an algorithm. The construction of the algorithm is the stage which requires creative thinking and finding the best possible combination of steps to get the result. For example, A. Algorithm to find product, sum and difference of two numbers. Step 1. Start. Step 2. Read two numbers and store them in A and B. Step 3. Multiply two numbers A and B. Step 4. Print the product. Step 5. Add two numbers A and B. Step 6. Print the sum. Step 7. Subtract the number B from the number A. Step 8. Print the difference. Step 9. Stop. B. Algorithm to find the smallest in two numbers A and B. Step 1. Start. Step 2. Read two numbers and store them in A and B. Step 3. Compare number A and B. If A is less than B, print A is smallest and go to step 5. Step 4. Compare number A and B. If B is less than A, print B is smallest and go to step 5. Step 5. Stop. Defining flowcharts. A flowchart is a type of graphical diagram that represents an algorithm. It is a set of instructions that can be followed to perform a specific task, workflow, or process. This diagrammatic representation illustrates a solution model to a given problem. Flowcharts are used in analyzing, designing, documenting, or managing a process or program in various fields. Flowcharts show the sequence of instructions in a single program. They play a vital role in the field of programming. These are helpful in understanding the logic of complicated and lengthy problems. Once a flowchart is drawn, it becomes easy to write the program in any high-level language. Often, we see that flowcharts are helpful in explaining the program to others. Hence, it is correct to say that a flowchart is must for the better understanding of a complex program. Symbols used in flowcharts. different symbols are used to draw different types of flowcharts. Let us discuss them. Start or stop. It is used to show the start and stop points of the flowchart. It usually contains the words start or stop. Process. It shows a process or action step. This is the most common symbol used in flowcharts. Decision. It indicates a question or branch in the process flow. It is used when there are two options, yes or no. Input or output. It requires material or information entering or leaving the system, that is input and output. Flow line, arrow, connector. It shows the direction in which the process flows. Connector, inspection. It is small and is used as a connector to show a jump from one point in the flowchart to another. Connectors are usually labeled in pairs to show matching jump points. Rules to draw flowcharts. You must follow these basic rules while drawing a flowchart. The flowchart should be clear, neat, and easy to follow. Maintain the direction of the flow from left to right or top to bottom. Only one flow line should come out from a process symbol. Ensure that only one flow line should enter a decision symbol, but two flow lines should leave the decision box. Ensure that the flowchart has a logical start and end. Advantages of flowcharts. Flowcharts provide following advantages. It provides a better understanding of a problem. It facilitates a programmer to analyze the problem in detail. Let us understand how some simple flowcharts are made. Example 1. Flowchart to add first 100 natural numbers. Start. Sum is equal to 0. N is equal to 0. N is equal to n plus 1. Sum is equal to sum plus n. Is n greater than or equal to 100? If no, then go back to step n is equal to n plus 1. Is n greater than or equal to 100? If yes, then print sum and stop. Example 2. Flowchart to calculate simple interest. Start. Read P for principal, small r for rate, small t for time. Calculate SI is equal to, into bracket, P multiplied by R multiplied by T, bracket closed, divide by 100. Print SI, stop. Solving problems using algorithms and flowcharts. Example 1. Write an algorithm and draw a flowchart to calculate the factorial of a number. Algorithm. Step 1. Start. Step 2. Read the number n. Step 3. Initialize I is equal to 1, comma, fact is equal to 1. Step 4. Check if I is less than or equal to n. Then repeat step 5 to 6 until I is equal to n. Step 5. Fact is equal to fact multiplied by I. Step 6. I is equal to I plus 1. Step 7. Print fact. Step 8. Stop. Flowchart. Start. Read n. I is equal to 1. Fact is equal to 1. Is I less than or equal to 1? If true, then I is equal to I plus 1. If false, then print fact. Then fact is equal to fact multiplied by I. Then stop. Example 2. Write an algorithm and draw a flowchart to check whether a given number is even or odd. Algorithm. Step 1. Start. Step 2. Read number. Step 3. Check if number percentage 2 equal to 0. Then print number is even. Else print number is odd. Step 4. stop. Flowchart. Start. Read a number. Is number percentage 2 equal 0? If yes, number is even. If no, number is odd. Stop. Computer languages. To communicate with the computers, we need special languages which are called computer languages or programming languages. A computer language is the medium by which instructions are transmitted to the computer to perform a specific task. It is a set of words, symbols and codes that the computer can understand. It is used to write computer programs. A computer program is a set of instructions written in a programming language. The process of writing a program is called programming. People who write the programs are called programmers. There are a number of programming languages worldwide. Some languages were developed for specific computers. Others were developed for specific uses such as scientific or business applications. Computer languages are classified into two major categories. Low-level language, which is the machine language 1GL or assembly language 2GL. High-level language, which consists of third-generation language 3GL, fourth-generation language 4GL, natural language 5GL. Low-level language LLL. A low-level language is a programming language that is machine-dependent. A program written in machine-dependent language runs only on one particular type of computer. There are two categories of low-level languages. Machine language. Machine language is the only language understood by the computer. It is also known as the first-generation language, 1GL. Machine language is very difficult for programmers to use because it only consists of two digits, 0 and 1, called binary digits or bits, where the bit 0 represents the off state and the bit 1 represents the on state. Assembly language. Assembly language is also known as second-generation language, 2GL. It is the language in which program codes are written in the form of alphanumeric symbols called mnemonics, instead of 0 and 1. In the assembly language, a programmer writes abbreviations such as A for addition, C for compare, L for load, and M for multiply. Because of this feature, it is also known as symbolic language. High-level language, HLL. High-level language is a programming language that enables a programmer to write programs that are machine-independent. This type of languages are considered as high-level languages because they are closer to human languages and away from machine languages. The main advantages of high-level languages over low-level languages is that they are easier to read, write, and maintain. Let's discuss about some high-level languages. Third-generation languages, 3GL. In third-generation languages, the programmer writes a series of English-like words that tell the computer what to accomplish and how to do. Many third-generation languages also use arithmetic operators such as asterisk for multiplication and plus for addition. Some early procedural 3GL are BASIC, Pascal, C, and Fortran. Some other advanced object-oriented 3GL are C++, Java, and C#. Fourth-generation languages, 4GL. The fourth-generation languages also use English-like statements. They specify what the program should accomplish without explaining how. A 4GL is fast and requires less time and effort on the part of the programmer. In fact, 4GLs are so easy to use and programmers with very little programming background can develop programs. Examples of 4GL are SQL, Perl, Python, etc. Natural languages 5GL. The fifth generation languages, also known as natural languages, are the programming languages that have visual tools to develop a program. Examples of fifth generation language include Mercury, OPS5 and Prolog. Natural language is very easy to use. Natural languages are often associated with expert system and artificial intelligence. Advantages of high-level languages. High-level language is user-friendly and easier to maintain. High-level language is similar to the English language with vocabulary of words and symbols. Therefore, it is easier to run. High-level language requires less time to write a program. High-level language is problem-oriented rather than machine-based. High-level language is machine-independent. Disadvantages of high-level languages. A high-level language has to be translated into the machine language by a translator, and thus it wastes a lot of the computer time. The object code generated by a translator might be inefficient as compared to an equivalent assembly language translator. A language translator is a software that converts a high-level language program into a machine language. There are three types of language translators. Assembler. An assembler is a program used to translate assembly language into machine language so that the computer can understand it. The assembler enables the computer to convert the assembly language instructions into machine code, that is, zeros and ones. Compiler. A compiler is a software that converts the entire source into machine language before executing it. It converts the entire high-level language program into machine language at once. It displays the errors for the whole program together. Interpreter. An interpreter is also a separate program that An interpreter is also a separate program that converts the entire source program into machine language before executing it. It translates and executes one statement at a time. It displays the errors one line at a time and goes to the next line only after the error is corrected. Working of language translators. The programs written in a high-level language must be translated into machine language by using a translator called compiler or interpreter. 3 multiplied by 2 is equal to 6. That's a high-level language input. Language translator is used, which gives the output, that is the machine code 0100